Hello friends, in today's lecture we will study Masson's gain formula. Now using this we can easily calculate the overall transfer function, or you can say that overall transmittance, or it may also be known as your gain of a signal flow graph, or you can say that it's a control system represented in terms of a signal flow graph. And the formula is T, where T stands for transfer function, is equals to the summation pk delta k divided by delta, okay, pk delta k divided by delta, where pk is actually the forward path transmittance of kth forward path. Delta k is the path factor associated with a path k. Delta is the graph betterment, where delta is calculated like this, that is 1 minus sum of all individual loop transmittance and plus sum of loop transmittance products of all possible pairs of non-touching loops minus sum of loop transmittance of all possible triplets of non-touching loops, and so on. Okay, so in this way, if we use this formula for finding out the overall transfer function or gain of a signal flow graph, then we can easily calculate the. Let us take this example. In this example, we have to first find out the possible forward paths. Here you can see that we can choose this as first possible path, that is starting from x1 moving towards this way and reached up to x5. Okay, let us name it as p1, this forward path p1 with transmittance a, b, c, t, and the second path is like this. Forward path is like this. Let's name it as p2, and this p2 is equals to ag. Okay, now in second step you have to find out the all possible individual loops. This is a loop here, okay, this is a loop here, okay, and this is a loop here. Let us suppose this is your L1, this is your L2, and this is your loop 3 L3. So in this way, L1 is equals to F, the loop transmittance of L2 is CE, and the loop transmittance for L3 is DH. Now in next step, you have to find out the possibilities of pairs of non-touching loops. Here you can see here that loop 1 L1 is non-touching to loop 2, and this can be easily find out that by searching a non-common node, that is there is a zero common node between L1 and L2, that's why they are non-touching. So in next step we have to write the pairs of non-touching loop, that is L1 L2. You can name it as L12 is equals to FCE. Second, you can also see that there is no common node between L1 and L3, so we can write L1 L3 as another pair, that is L13, and it is FDH. So in next step you have to find out, that is step 4, you have to find out delta here. Delta is 1 minus L1 plus L2 plus L3, bracket close, with plus sign L12 plus L13. Okay, if we put the values, then we will get the result as F plus CE plus DH plus FCE plus FDH. Now next step, you have to find out the path factor. Path factor here comes for path 1 and path 2. The path factor is calculated, you have to subtract the portion of the path which is non-touching to the forward path. Here you can see here that every part is connected or touched to this forward path P1. Okay, so the path factor will be 0. It means whenever there is no such portion which is not connected to a particular path, then you have to subtract 0 from 1, and that will be the respective path factor. And the second path, that is for this part, yellow part, you can see that when we move from x1 to x2 and then x5 through this yellow path, then there is a portion, that is L2, which is non-touching to this forward path P2. So we have to subtract this part from 1, that is 1 minus L2, that is 1 minus CE. So in this way, the transfer function T will be P1 delta 1 plus P2 delta 2 divided by delta, and P1 is nothing but A, B, C, D plus P2 is A, G multiply 1 minus CE divided by this complete value, that is 1 minus F plus CE plus DH plus FCE plus FDH, and this will be your complete final answer. Okay, thanks for watching this video.